Welcome to Wildcat Science with Mrs. Haugo. This is Physical Science 1.4, the Magnetic Force Experiment, Part 2. So please take a moment and go to Classroom and open up the 1.4, the Magnetic Force Experiment Google document. And then it should look like this. So 1.4, the magnetic force, the purpose, we will measure how the magnetic force changes as the distance between two magnets change. And then let's get started with our procedure. Obtain a spring scale and a magnetic force apparatus. And do not drop the magnets. That should be pretty easy for you. Okay, question 1. How will we use the fact that all the spacers are the same thickness to find the most accurate value for the thickness of one spacer? So we get out our spacers and we can see that they are actually quite thin. So it's hard to measure the thickness of one of them. But if we put them all together and then measure them all together and then divide by that number, then that will be easier. So I'm going to put them all together. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of them. And when I measure that very precisely, I get 1.1 centimeters, or we know that there are 10 millimeters in a centimeter, so 11 millimeters total, and we know that there were 10 of them, so 11 divided by 10, and you're going to put that answer right there. If you need a calculator, that's fine, or you can move the decimal point over 1. So, what is the thickness of one spacer in millimeters to the nearest tenth? Well, 11 divided by 10, well, that would be 1.1, and then millimeters. So we kind of skipped question 1, but you saw me do it. How will you use the fact that all the spacers are the same thickness to find the most accurate value for the thickness of one spacer? So we measured the thickness of all of the spacers, and then we divided by 10 to get the thickness of one spacer. So please pause the video and write that down. Great, then moving on to number 2. Connect the magnet and the spring scale and zero the spring scale by turning the nut at the top and stack 6 spacers on the apparatus to make a total of 8 spacers. So I'm going to connect the magnet to the spring scale, and then you might be able to see that it's not at 0, so I'm going to turn the nut until the top of the force indicator is at 0. Then I'm going to stack 6 spacers on the apparatus to make a total of 8 spacers. So you can see that there's already 2, and then I'm going to add 6 more. 1, 2, 3, 4, 5, 6. Okay, so now I have a total of 8 spacers. And then I'm going to position the magnet on top of the apparatus and slowly pull the spring scale straight up, calling out the readings as you increase the pull or the force until the magnets separate. Okay, so we have our force apparatus, and then I'm going to call out the numbers as I pull up. It is 0.5. Oh, there we go, and it separated. So then I'm going to come down here and let's see, 8 spacers. My distance was, well, it's 8 times 1.1, so 8.8 millimeters right here. And then force 1 was 0.5 newtons. And now let's try that again. So it's 0, 0.1, 0.2, 0.3, 0.4, 0.5, and again 0.5. So put 0.5 newtons right there. And for our third trial, 0, 0.1, 0.2, 0.3, 0.4, 0.5. Again, very consistent. 0.5 newtons. We'll do the average in a minute, but let's come up here to number 6. Write down the amount of force needed to separate the magnets and put information into the data table. Repeat step 6 and 7 2 more times. Well, we already did that. And find the average of the 3 readings. Well, 0.5, 0.5, and 0.5, you add those all up together and divide by 3, you'd get 0.5 newtons. So now we're going to remove 1 spacer and repeat all of these steps all the way until we get down to 2. So let's look at 7. So I'm going to remove 1 spacer. Question for you is, will the force increase or decrease now that we have a smaller distance? So let's start out with our distance. We have 1.1 times 7 spacers, and put your answer right there, and make sure you put a unit. And let's do force 1. Oh, wrong side. Okay, it is 0, 0.3, 0.4, 0.5, 0.6, 0.7. That was 0.7 newtons right there. Let's try that again. Trial 2. We have 0.3, 0.4, 0.5, 0.6, 0.7. Yep, 0.7 newtons. And now on to our third trial. 0.4, 0.5, 0.6, 0.7. So 0.7. And then to get our average, we're going to do 0.7, 0.7, 0.7, all added together, divided by 3. And then make sure you have the unit newtons. And then we come down to 6. I'm going to remove 1 spacer. And then my distance would be 1.1 times 6. And then make sure to put units, millimeters there. And then force 1. So we've got 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Ooh, that was 0.9. 0.9 newtons. And force 2, we have 0.3, 0.4, 0.5, 0.7, 0.9. Again, 0.9 newtons. And force 3, 0.4, 0.5, 0.6, 0.7, 0.8. Ooh, let's try that one again. I didn't quite get it. 0.5, 0.6, 0.7, 0.8. Yep, that was 0.8 newtons. So now for the average, you might need to get a calculator or find the calculator on your Chromebook. 0.9, 0.9, 0.8. Add those all up together and divide by 3. And then put your average to the nearest tenth and make sure to write newtons. Once you have that done, we're going to come down to 5. Remove 1. Now I have 5 spacers total. And we have 0, 0.5, 1, 1.1, 1.2. Oh, 1.2. Oops, 1.2 newtons. And then let's go back here. And we have 5 times 1.1 1, and then put your answer with millimeters. And then we had 1.2 newtons, and going over to trial 2. 0.5, 1, 1.1, 1.2, again, 1.2 newtons. And then trial 3. 0.5, 1, 1.1, 1.2, again, 1.2 newtons. So 1.2 newtons. And then our average is 1.2 plus 1.2 plus 1.2 and divided by 3. And write that to the nearest tenth of a newton. You could probably do that in your head. And number 4, 4 spacers total. I'm going to remove 1. The distance is 4 times 1.1, and then put your answer with millimeters. And now force 1. So we've got 1 newton, 1.3, 1.4, 1.5, 1.6, 1.7 newtons right there. Let's do trial 2. We have 0.5, 1, 1.5, 1.6, 1.6 newtons right there. And then trial 3. We have 1, 1.5, 1.6, 1.7, 1.7 newtons. Please write that down there. And then we have 1.6 plus 1.6 plus 1.7 newtons, and you want to add those up and divide by 3. And then we'll come over here and I remove 1. So we have a total of 3 spacers. So 3 times 1.1 equals how many millimeters? Write that down. And then let's move to trial 1. Okay, so I have 1, 1.5, 6, 1.7, 1.8, 1.9, 2, 2.1, 2.2, 2.3, 2.4, 2.4. So please write 2.4 newtons there. And then let's do trial 2. My force apparatus kind of fell apart there. Okay. So we've got 1, 1.5, 2, 2.2, 3, 2.5, and that was 2.5 newtons. So 2.4, 2.5 newtons. And then trial 3, we have 1, 2, 2.2, 2.3, 2.4, 2.5 again. 2.5 newtons. And then coming over here, our average, 2.4, and then I believe it was 2.5 and 2.4, but you'll have to check me on that. Add those 3 up and divide by 3 and put your answer to the nearest tenth. And then 2. So we're left with only the permanent spacers. And so that's 2 times 1.1 equals how many millimeters? Then coming over to trial 1. Got 1, 2, 2.5, 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3. That was 3.5. So put 3.5 newtons there. And now trial 2. Got 1, 2, 3, 3.4, 3.5, 3.6. 3.6 newtons. And then for our last one,